Hi students, in this video we are moving on to the last part of the integration, and that is integrating the exponential and the logarithmic functions. So do get ready a pen and some papers and practice along with me. Let's look at what are the concepts that are needed in this video. Let's recall how you differentiate e to the power of ax plus b. What you'll be getting is just e to the power of ax plus b multiplied by the differentiation of the power which you will get will be a times e to the power of ax plus b. And since integration is the reverse process of the differentiation, we've been doing this numerous times. I'm going to pull out a because a is a constant, and this goes off because it's the reverse process of each other. And I'm going to divide by a, but dividing by a is the same as multiplying both sides with 1 over a. Right, so integrating e to the power of ax plus b will give you 1 over a e to the power of ax plus b, and of course not to forget our constant c. Now for the logarithmic functions, right, if you were to recall, when we differentiate ln bracket ax plus b, you will get 1 over ax plus b multiplied with the differentiations of whatever inside the bracket, which is ax plus b, and that gives you a. You end up getting a over ax plus b. And if we will do the same process as what we have done earlier on, add the integration sign to both sides, pull up your constants a, because a is a constant, multiply by 1 over a on both sides, and this is what you get. Of course, not to forget a constant c. Right, so these are the concepts that are needed, okay, for the rest of the slides in this video. Right, having learned the concepts of how we can integrate exponential functions, let's put it into practice. Let's look at 1a. Right, you can just pull out your -2 because it's a constant. Now, integrations or differentiations of exponential functions are rather easy. Whatever you see, you just write it down. For integrations, is whatever you see, you write it down, then you divide by the differentiation of the power. If it's differentiation, you just write down whatever you see times the differentiation of the power. So here you will get -2 first, yes, times e to the power -2x divide by the differentiation of the power, differentiate -2x, you get -2. And you simplify further. Right, this is what you get. So let's do a recap. This is very important. You must be able to convert a to the power of -n to 1 over a to the power of n, and vice versa. Both ways. Okay, you must be able to do that. It's very useful. Right, let's look at b. Okay, so whatever you see there is e to the power x over 2, right? Then just write it down. Then divide by the differentiation of x over 2. X over 2 can be written as half x, as I've already explained it before. X over 2 basically is just x over 1 times half, and that is just half x. So differentiating half x, you get half. Okay, and you can do the simple trick here, times 2 at the denominator, times 2 at the numerator. That's how you end up getting 2 times 2e to the power x over 2, because this will end up giving you 1. And of course, not to forget your constant c. That's very important. Let's look at part C. So in these questions, we're just basically applying the formula that we've learned. All right, part D. So from here, you can see that all this constant negative 2, 3, 5, you can just pull it out from the integral sign. Right. Okay, so it's yeah, it's not that challenging. Right. So for the integrations of the logarithmic function, is more challenging than exponential, yes, because there are more steps involved. Let's look at 2a. 2a, we can pull out 3, right? And if you were to recall what we did earlier on, differentiate ln x, you get 1 over x, right? So integrate 1 over x, you'll get back 3 ln x. You get back your ln x, then times 3 plus c. Let's look at b. That will give you ln bracket, yes, x minus 1 plus c. Let's look at part c. All right, part c will involve one more step. That is, you need to divide by the differentiation. In this case, it's not the power, but the denominator. Divide by the differentiation of your denominator. So what you get will be ln bracket 2x plus 1 over 2. You differentiate 2x plus 3, you get 2. And you can write it as halved ln bracket 2x plus 3, then plus your constant c. Oops, I forgot my constant c. This is important. All right, let's look at part D. Let's simplify. Part D, let's simplify it before you integrate it. So you can actually factorize 2 from your denominator, and that will give you, yes, and that will give you ln bracket 1 minus x. Yes, always remember to divide by the differentiation of your denominator. Or if you find it difficult, just remember the differentiations of whatever inside the bracket. That's another way to look at it. So here we're actually dividing it by differentiation of x is 1. Okay, so we didn't actually include that. This part here also, you differentiate x, you get 1. So it's over 1. So just get back ln bracket x minus 1. Okay, and then you can just put the negative to the front, then plus constant c. Okay, let's look at part E. All right, so that will give you, yes, okay, and yeah, plus c. Let's look at F. You'll get ln bracket 3 minus 2x divided by negative 2. Okay. Right, so look at the problem sum. So we have a curve, y equals to f of x, and the particular point it has gradient x squared plus e to the power of 2x. So if 0, 2 lies on the curve, find the equations of the curve. All right, so we'll start off with dy over dx equals to x squared plus e to the power of 2x, the gradient function. Okay, we start off with having the gradient function. And then because we're finding the equations of the curve, so which is f of x equals to something, which is going to add the integral sign. We've done it numerous times, right? Yes, and how do we get that? Because this and this will cancel off each other, so you get f of x. Integrate x squared, you get x cubed over 3. Integrate e to the power of 2x is e to the power of 2x divided by 2, plus a constant c. And we need to find the value for constant c, so this is where this point comes in. So put it back into your equations of the curve. Right. So since you're told that y is equals to f of x, that means y is equals to 1/3. Equations of the curve will be y equals to 1/3 x cubed plus half e to the power of 2x plus 3/2 plus a constant c, where c is arbitrary constant. Right, so let's look at 8a. If you look at what you're given at 8a, you will see that we don't have a formula to integrate that. So whatever rules that you used, you must always remember that it is something we've learned, something that's recognized, something that's been approved, right? So for these questions, you can't do it this way. Right, you can't do it that way. Okay, because in the previous video we do have a questions that actually allows us to prove that integrations of something like that is not equals to it's not equals to the products of these two integrations. You can't do it. So therefore, you have to think of another way. And if you were to recall that we've learned something earlier on, something called partial fractions, where you can actually separate this into two fractions. And if we can do that, then we can actually integrate it separately. Right. So partial fractions, if you've forgotten, do revise. There are few rules for partial fractions. When your denominator comprises of linear factors, what do you do? When it comprises of repeated linear factors or the quadratic factors, quadratic factors, yeah. What do you do? Or when you are given an improper fraction. So that are the four rules that you have to revisit. So this one we are given a linear and a repeated linear factor. So for linear, it's rather easy. You just let it a over bracket x plus 1. For repeated, will be b over x minus 2, the first factor, and then c over the repeated one. Okay, and then we're going to combine them into a fractions. And we're going to use substitution method. So if I've forgotten this one, I'll put the video link and you can refer to it to do some revisions. I'm going to let x to be -1. I'm missing 1 here. So if you let x to be -1, basically your b and c will be gone. Left only with the values of a to be found. That gives you a equals to 1. Let a equals to x equals to 2. Oh, sorry. This one is 2. Let x equals to 2. Oh, that's where I'm missing 2. Okay. Let x equals to 2. So your b and a will be gone. Left only for c to be found. And finally, just let x to be 0. 0 is the most versatile number, I suppose. Anything times 0 gives you 0. So that gives you b equals to -1, and you put everything back into your partial fractions. Okay, that's what you're supposed to get. Alright, so now we have separated these fractions into 3 partial fractions. Then you see that I can just apply the rule, apply what we have learned earlier on. So you integrate 1 over x plus 1, basically just give you ln x plus 1. Integrate 1 over x minus 2 ln bracket x minus 2. And of course, this one here, you would have to convert it into your negative index, pull out the constant 3. So this one here, if you were to remember how we integrate ax plus b to the power n dx, right, we just power plus 1 divided by a times n plus 1 plus c. Right, so we just take negative 2 plus 1 gives you negative 1 divided by negative 1 times differentiate x minus 2 gives you 1. Right, then you simplify further, and this is how you do it. Right, let's look at 8b. So for 8b, you will need a little bit more algebraic manipulation because if you look at the denominator, right, some of you may be tricked into thinking that maybe you are tricked into using ax plus b for x squared minus 1 because you're tricked by the power of x, thinking that it's that you need to use ax plus b. But if you were to think further, you will realize that ax squared minus 1 can be factorized into x plus 1 and x minus 1. So sometimes while solving problem sums, you need to think a bit deeper. You just don't look at the surface. So x squared minus 1 can be factorized into x minus 1 and x plus 1. And then you can combine x plus 1 into a repeated linear factor. Right, so then you will realize that right, you cannot use ax plus b over x squared minus 1. Alright, you'll be using a over x minus 1 and also b over x plus 1 and c over x plus 1 squared. So the method that you use will be different really. Okay, then we're going on to find the unknowns a, b, and c. So this we're going to use substitution, right? So first of all, let x to be negative 1, so you can eliminate a and b to find c. Then x equals to 1 to eliminate b and c to find a. And finally, use the versatile number 0 to find b. And with that, you can plug into, yes. So now we have 3 partial fractions, and we can just go ahead and integrate it. Alright, so now we have separated the fractions into 3 different partial fractions. Okay, so now we can just integrate it. So basically, you can just pull out 1/4, and you'll get 1/4 ln bracket x minus 1. Likewise, for the second one, you can just pull out your 1/4, so that will give you negative 1/4 ln bracket x plus 1. Right, so this is a bit troublesome. You have to convert this into bracket x plus 1 to the power negative 2, then pull out the half. Right, and then the power plus 1 divided by the power times differentiation of x plus 2, but differentiate x plus 2 gives you 1. And you simplified it further. Okay, and that's your answer. Alright, so this is what I mean by you need to learn the 4 different methods, to how you can actually simplify fractions into partial fractions. So if you look at 9 part I, alright, we're given a improper fractions. Okay, improper because the highest power of a numerator is equal to the highest power of a denominator or more. That is improper. And improper, you will have to administer the long division. Okay, you have to do the long division and to write it in the form of quotient plus remainder over divisor. This is your quotient. This one is your divisor. And this is your remainder. Okay, right. Okay. So that is 9 part I. So for 9 part 2, we need to differentiate it. Alright, so we're going to use a product rule. Let u to be x, so du over dx is 1. Let b to be ln bracket 3x plus 5. So if you were to follow my videos, you will realize that the type of questions that that you're being exposed to, the skill to solve them, basically the same, right? The only things different is the presence of interest that is not the same. For example, if the questions involve exponential, then you must know the rules. You must be able to know how to integrate exponential functions. If the problems involving log, and then you must know how to integrate logarithmic functions, or if it's involved trigonometric functions. Okay, but you will see that the way they ask the questions is being phrased more or less. They can't test you anything that is the type of questionings are more or less the same. Like given this gradient function, what do you do? Just integrate it to find equations of the curve. Okay, right. So we're going to use the product rule to differentiate that. If you remember your product rule, that is u dv over dx plus v du over dx. Okay, and right, so that is part 2. So for part 3, you're asked to use the result for part I and part 2. So let's write down the results we have found for part I, and also let's write down the result we found for part 2. Okay, and we're going to use part 2 first. We're going to add the integral symbol to the equations. Okay, and I'm making this a subject. I'm making this a subject because this is exactly the presence of interest here. Right, and this cancel off each other, the reverse of each other. Okay, so this is already done, right? We can't do anything more to that. However, this part here is where we need to use what we have found in 9 part I. Without it, we can't integrate it. So this is a bit tricky here because of the negative sign, right? So we have to be careful because this and this will give you a positive. Okay, so that's how we do question 9. All right, let's look at question 11. So for question 11, you've been given a curve y equals f of x such that the derivative means your dy dx. It means d of f of x. This is what you mean by derivative. Or since y is equals to f of x, it means dy over dx equals to e to the power negative 3x plus 3e to the power x. Okay, so for part I, we are asked to explain why the curve has no stationary points. So basically, if we can explain that your dy over dx is more than 0 or less than 0, it means that it has no stationary point. Okay, so this is the way to go. To explain whether a curve has no stationary point, you just explain that dy over dx, basically the value for dy over dx is more than 0 or less than 0. Then for part 2, you're asked to find the equations of the curve. Expression for f of x means to find the equations of the curve. So let's look at part I first. Okay, so this is what I've explained just now. Yes, and exponential function is an exponential function. It's always positive. If you recall your exponential curve, right? It's always more than 0 for both, and so therefore you end up having the dy over dx or dfx over dx to be a positive value. And if it's a positive value, it's either an increasing or decreasing. It is increasing function because now it's more than 0, so it's increasing function. Increasing function, you won't have a stationary point. You only have stationary point when you manage to have dy over dx equals to 0. Okay, so hence y equals to f of x has no stationary points. So this is the way to go about proving something has no stationary point. Okay, so for part 2, yes, we're going to add the integral sign. We're going to integrate it. That we have done this numerous times already. All right. This and this will cancel off each other. Right. So you integrate e to the power negative 3x, you get e to the power negative 3x divided by negative 3. Right. Integrate e to the power x with e to the power x. Why 1? Because you need to divide by differentiation of the power. Differentiate x, you get 1. Because I always do that even if it's integrate e to the power x. Okay, so to remind yourself that you need to divide by the differentiation of the power. So how do I find the constancy? So usually they will give you see, in the question they will give you 1 point where you can make use of to substitute into the equations to find the unknown c. Okay, and that's it. Right, so question 12. If you're losing steam, take a break. This is the second last question. We're coming to the end very soon. So for 12i, yes, this questions in putting differentiation, because in differentiation integrations are more or less, not more or less, they are connected to each other, right? So usually they would, test you first part, differentiate, and then use what you have found, to do some integration. So for first part, we're going to use the quotient rule. Okay, and if you remember, for the differentiation of logarithmic functions, right? You remember that, okay, logarithmic functions are a bit troublesome because, yeah, differentiation of logarithmic functions, you recall, we advise you to simplify the expression using the logarithmic rule. The 3 rules that we've learned, the ln bracket AB gives you ln A plus ln B, ln A divided by B, and the power one, power ln A to the power B. So this is what I've used, the power one, bring the power down to get 3 ln x, and I just need to differentiate ln x. Okay, 3 is a constant, so I will get 3 times 1 over x. That's for u, and v is x squared, so dv over dx is 2x. So put into your quotient rule. Okay, if you quotient rule, v du over dx minus u dv over dx over v squared. That's the quotient rule. Simplified it. Okay, separate into 2 fractions. Simplify further. Okay. This is x to the power 1. This is x to the power 4. So you end up 1 over x to the power 3. Okay, this and this can goes off, right? Give you x to the power 3. And you can use back your product rule. Not product rule, wrong. Power rule. For your logarithmic function, put the 2 up to your x squared. You get ln x squared. The power rule here that we've mentioned just now. Okay, so we have just shown what we're supposed to show. So for part 2, make use of part I's answer. Add the integral sign, and then these two cancel off each other. Okay, and make this the subject, because you're finding this. Integrate this means we're finding this, so make that the subject. And we're going to multiply by 1/3 throughout. Okay, because if you look at what you're supposed to find, there should not be a constant 3 there. So we're just going to times 1/3 throughout. So this is what we get. 1/3 times 3 gives you 1. Yes, convert your x to the power 1 over x cubed to be x to the power negative 3. So this one you can just add 1 and divide by negative 2. And yeah, this one basically you already done the job. So just times 1/3 will do. Alright, then why do I get the 3 here? It's because this one apply the power rule again for your logarithmic function. This can be written as 3 ln x. Right. Why do we want to do that? So that this, if I put the 3 down, can you see I have a 3 at your denominator, also 3 at the numerator. I can just cancel off to make it more simplified. Okay, and not to forget, you must always add a constant c because we're dealing with indefinite integral. Right, this is the last question, and it's a very interesting question. Yes, it's very interesting questions because for logarithmic integrations of logarithmic functions, this is what will happen. Some of you may get a different answer, but and then you may worry, am I doing it correctly? So you just remember that if you are applying the rules correctly, following the rules, not using your own rule, but using what is being approved or what you have learned, then you should not worry too much about getting a wrong answer. So there are 2 different solutions presented by 2 different students, and then which one is correct? So let's look at student A first. Right, so if you look at student A, let's look at the how we go about integrating what is given first. Alright, so I'm just going to pull out half, because half is a constant, and I'm just going to apply the integration rule to integrate 1 over 5x minus 1. So that gives you, yeah, so I'm not doing anything that's wrong, right? I've just applied the rule, this rule here that we've learned earlier on. Integrate 1 over ax plus b dx gives you ln bracket ax plus b over a. Right, so I've just applied it correctly. I've not done anything wrong. And then I can just yes, multiply the numerator and the denominator to get 1 over 10. 5 times 2 is 10. All right. So if you look at student A, that's exactly what student A has done. The answers, right? So student A has not done anything that's wrong. Student A is correct. But if you look at student B, right, so what student B has done is he actually expand this, okay, expand this to get 10x minus 2. And then he apply the rule, which is ln bracket 10x minus 2 divided by 10. Okay, sorry, I just went to frighten off some birds. It's causing me a lot of problem. Okay, right, and then plus a constant c. So, so actually, student B is not exactly wrong, but why is it not exactly wrong? Because c is an arbitrary constant, so I can actually simplify students B to be yes, I can actually simplify 10x minus 2. Hello, go away. Sorry. Simplify 10x minus 2 to be 2 bracket 5x minus 1. And then you can apply the product rule for logarithmic functions. Okay, this one here. This is like your ln AB. That gives you ln A plus ln B. And then you can expand it And this is also, this 1 over 10 ln 2 is a constant. So this constant and this c, you can add them together to have another, just use a letter d. You don't use c anymore, just use a letter d to represent it, where d is an arbitrary constant which is equals to. Alright, so basically student B is not wrong also. However, okay, if you ask me which one is the preferred solution, I would tell you student A. Why you want to go through the trouble of, if you're given, you see what I mean is that if you're given an expanded form, right, you can just pull up the fractions half. Why do you want to multiply in and then, you know, make it more complicated? Because by right, this answer can be simplified further. Yes, it can be simplified further because 10x minus 2 can be simplified as 2 bracket 5x minus 1. So that is what exactly that's given to you in the first place. So if that's what is given to you in the first place, then you don't need to, don't do extra. Don't do extra. Just work with what you're given. Right, so even though student B answers is not wrong, but it's not simplified. So student A's answer is a better one.